Hi, my name is Lucy Rowland.
I'm Rosie Welch.
I'm Spencer Kelly.
I'm Roa Kedad.
And we are Group 4 of Iowa State University's Senior Design Capstone class. And for our project, we worked with Danfoss at their Ames location to redesign their H1 tandem pump line.
The overall objective of our project is to redesign the H1 tandem pump line in order to meet the increasing demand. The current line was designed 10 years ago in-house and is already at capacity. We are also trying to reduce the number of workdays from 7 to 5. As you can see by the forecasted demand chart, the demand for Danfoss's H1 tandem pump is only increasing and shows no signs of slowing down anytime soon.
For the current state, the group used many different approaches. Our main method of analysis was to use observed time studies, and these timings we would use during our current state and our future state to build different staffing level charts and our Simeo model. Other methods that we used was our work sampling study, as well as an employee questionnaire, and building our current state Simeo model to reference later on in our future state design.
For the observed time studies, the group's main focus was on the expected bottleneck of the line, the testing area. Limited data had been collected on these stations before, so many timings were collected to gain insight on this problematic portion of the operation. To complete a thorough analysis, the group also observed the rest of the line across all shift periods, where we gained a full understanding of how the line operated and where the opportunities for improvement lied.
Two main methodologies were used. The first one was the cycle time bar chart. The information from the cycle time bar chart came from the time studies done in the current state analysis. The main goal of the cycle time bar chart was to staff the correct amount of operators that gave us the most units per labor hour while still meeting TACT. The second methodology we used was the Simeo model. The Simeo model also used distributions gained from the time studies. The Simeo model gave us an idea of our throughput given variability and tested reliability. Both of these methodologies led to our recommendations for our solutions of the future state.
After analyzing the collected data from the H1 line, our group presented 3 solutions to our client. The first solution is to be implemented now. We balance the line by choosing the ideal staffing level. This staffing level ensures the maximum units produced per labor hour while under takt time. The second solution is to be implemented in 1 year to meet the increasing demand that's forecasted for that period. Our client wants to change the operation from 7 days per week to 5 days per week. To accommodate for the increasing demand with a 5 days per week production, some of the work content in the stations were shifted and readjusted to better balance the line. The third solution is designing a new line with a new layout. This line will have an additional tester, automation that will replace some of the work content to reduce the setup time, and conveyors that connect all stations to eliminate hoist movement and improve safety.
Since the H1 line was at capacity and running overtime, there was plenty of opportunity for economic impact. The economic impact of the project was determined by comparing the cost of not implementing the project to the total investment. The main costs avoided were overtime for 2019 and 2020, as well as the lost sales due to the forecasted demand of 2021 and 2022. With an investment of $3.7 million in a new line and testers, Danfoss can avoid the cost of overtime and lost sales totaling nearly $33 million in the next 4 years.